talk by international speakers. And we are honored today to have with us Dr. Amir Hussain for the keynote speech. Dr. Amir is a professor at School of Computing, Edinburgh, Napier University, UK. He has co-authored 3 international patents, and he has published in 500 plus internationally recognized journals, conferences, and books. He bears a citation of 21,000 and has an H index of 16.9. Dr. Amir's research interests are cross-disciplinary and industry-led, and he aims to develop and commercialize cognitive data sciences and responsible AI technologies. So without further ado, I would like to request Dr. Amir Hussain to please come on the stage. Thank you very much, sir.
Okay, Assalamu alaikum warahmatullahi wabarakatuh. Thank you for the kind introduction. Honorable Chief Guest, distinguished guests, ladies and gentlemen, it's an honor and a privilege to be here. I'd like to thank the conference organizers for giving me the opportunity to come and share some of my thoughts and views on some of the work I've been doing. And also to invite new collaborators from Bahria, which I'll talk about towards the end. It's a bit about my background. So I'm an engineer by training, and been working in a few places as I've listed there. So where I work currently is in Edinburgh. So I'm sure you all know where it is. It's the capital of Scotland. So sorry, I must add, this was prepared for a 1-hour keynote, but I found out it's a 20-minute sort of duration that I have for this talk, so I'll be skipping through a lot of the slides, so please excuse me for that. So some of the projects I've been leading in this area of trustworthy and responsible AI, which I'm currently leading on, alhamdulillah, and I'll talk about some of them as part of this talk. Sorry, just an overview of what I'll be talking about. So my vision, what do I mean by trustworthy, responsible AI? Some of the challenges and opportunities that I've identified through my work and also the work of others. Some use cases I've been working on over the past few years and that I'm also working on currently. And then finally, I'll talk about some new collaboration opportunities. So university, very briefly, so Edinburgh Napier University. So Napier, for those of you who don't know, is a famous mathematician who discovered the logarithm. So so the university is named after him. And we're doing pretty well in research, especially in terms of the research power and the impact of our research. So taking our research from the labs to the real world. And as I think the chief guest yesterday mentioned, that really the aim of our research really needs to be to generate impact on the community, on the society, both nationally and globally. Otherwise, we're wasting our time, right? So that's the reason why I'm in that university, and I'm sure all universities share the same vision and same ethos. So that's really what I'm interested in doing. So working on high impact use cases that can generate a lot of impact. And hopefully I'll give you some examples of that, inshallah. So what do I mean by trustworthy and responsible AI? So people use these words interchangeably. There's also called it ethical AI. So I think what I've from my experience and from my review of what others are doing in this area. So I think you could probably characterize trustworthy and responsible AI as those AI technologies that exhibit these 4 key characteristics I've mentioned here. So they need to be interpretable. In fact, I would say that in the future, they would need to be self-explaining, so explaining how they arrived at their decisions. A lot of the AI models, a lot of people are are learning about and using are kind of black box type. They solve the problem, but they can't explain why they've solved it. And that's obviously important, right? Especially in applications like healthcare, for example. Yeah, so if they make a wrong decision, then what went wrong. So interpretability is key, as is security, privacy preservation, of course, of the data, sensitive data, personal data that we're dealing with. They need to be ethical, and I'll talk about that later on. And also green. This is an interesting kind of recent emerging trend in this AI. So people are looking at the environmental impact of AI. Okay, so I'll talk about that as well. So in terms of the vision, I think we need to be looking to develop sustainable environments, for this ethical or responsible research and innovation ecosystem to thrive, right? And for that, we need to develop these national and global standards and benchmarks for evaluating AI models, not just to develop, but also evaluate these models. And that's what's currently missing. I'm sure you'll all agree with that. And I think we need to focus on high-value use cases, as I call them, right? So use cases that can generate maximal impact. So I was saying to somebody earlier on in a talk that I think somebody comes to me with a proposal, right? I say, well, okay, who are you targeting? Who's your target kind of audience or end users? They say, well, it's these, sort of smart applications that are going to make the life better of the elite people at the top whose life is already pretty comfortable. I said, well, I won't be much interested in that. But if you tell me you have a proposal for an application that is going to perhaps improve healthcare in those deprived communities, right? Where, with infrastructure is not there, I'll be more interested in that proposal. So that's what I mean by high value, okay? Where you can maximize, more of the people. And as you know, most people in the world are, underprivileged. We all know about, the global inequalities, especially in healthcare, for example, which is one of my main areas of interest. Okay, so I think responsible, trustworthy AI, if you can actually use them to help reduce those global inequalities and also national and local inequalities, for example, in healthcare, in the economic system as well, is a huge grand challenge there. Okay, so that's really what kind of motivates me, right, to work in this area. But I'll talk about some of the challenges and opportunities around these. Yeah, and some recommendations as well as part of this discussion. So, so in terms of red and green, so what do we mean by red and green, right? So red, I'm sure you'll all agree, is, an example is the Human Genome Project. So it cost a lot of money over a long period of time. Was it worthwhile, worth it? Perhaps. Now you can get, you can map an individual human genome in a few hours for $100. Obviously, it cost $2.7 billion. So maybe so some red AI use cases may be worth it. You need to think very carefully, right? But in general, red AI is not sustainable. Why? Because of the environmental concerns, right? The huge computing cost. But I think equally importantly for me, and I'm sure for everybody, is that it's not very inclusive, right? So there's entry barriers, for these kind of, high value, a lot of the high value use cases, you need, where big data is involved, especially, you need access to high compute resources, these servers and GPUs, which most people can't afford, right? So only these, researchers and innovators with access to those big resources are able to work on those kind of red AI projects, okay? So we need to try and change this, right? Okay, so what we call is green AI is basically more sustainable AI, where you can actually, everybody, researchers here, students, professors, in their laptops, they can actually, there should be, so get to that sustainable green AI, we need to develop and focus more on energy efficient AI models, okay? So that's a huge area of interest for myself and for a lot of people, okay? So that should be one of the key performance metrics, right? When you're evaluating AI models, so look at the energy efficiency, not just their performance, okay? And I'll talk about what other, trade-offs we need to keep in mind when we're working on developing these models. Okay, so that's a take-home message. Red AI is not sustainable, okay? Reproducibility is key. I'm sure you'll all agree with that as part of, ethical and responsible AI research and innovation. We need to make sure that our work is reproducible, applies to all of us, everyone. And it's good to see some of the top conferences like NeurIPS, for example. It's a requirement that, every paper must be submitted with its code as well. So maybe, organizers of this conference can also think about this for the future. And then of course, as you know, there's this kind of a rat race now, between, Intel and a lot of other companies, they're all trying to maximize its performance per watt. So I see it as kind of primarily, currently it's all around people looking at solutions that are systems on chip versus, computing in the edge or cloud. And as I'm sure the people who worked in this, they'll know that you're never going to get everything right. We're not living in paradise here. It's all about trade-offs, right? And I think beyond trade-offs, I think it's about user preferences. So for some people, for some applications, the performance is more important than maybe the power consumption or the size. And for some, latency, as I'll talk about in one of the use cases, latency is actually is fundamental for an application to be practically useful, okay, or realizable. We need to understand, of course, as we know, as I mentioned earlier, a lot of the AI models out there are black box type, so they're not interpretable. So we need to understand more of the science, the neuroscience behind how these deep neural networks work, okay? And also involve experts in the loop as part of the what I call co-creation. So we need to have the end users and the other domain experts working with us, as we are developing, training, and evaluating these AI models to maximize the possibility of their uptake, right, and their commercialization. Okay. Democratize, of course, we need to be sharing tools as widely as possible across all applications. A lot of still untapped applications, where AI tools have yet to be explored. So that's what I mean by democratization. Of course, security, privacy, as I mentioned earlier. This is actually an important point here. So need for ethical, or what I call fairer AI solutions. Now, this is actually important. I'm sure for people who worked in AI, you know that AI is also kind of called data science because you can't do anything without data, right? So imagine all of the data that we have, this legacy data, especially in healthcare, for example, and I'm sure in other applications as well. So this data is full of biases, isn't it, right? So if you think about data that's been captured, is it representative of all the populations or all the different segments of society? It's not, right? So imagine you have these minority groups, right? So their data is probably not represented proportionately in the data sets. So what will happen if those biases and inequalities are intrinsic in those training data sets? What's going to happen? So these AI models, they're actually going to not just learn those biases, they'll actually end up exacerbating or increasing those biases and inequalities rather than reducing them. Okay, so we need to look at that very carefully. Look at the biases in the whole ecosystem, right from the data set that we're collecting, we need to make sure we're capturing the right data, right? It's representative of all the populations that we need to train these models on and evaluate on, okay? And I think as a part of that, I would say, and as I'm sure you will have heard about these use cases in the media, in the US, for example, they're trying to develop these AI models to catch criminals or terrorists and end up, catching all the black, the black Americans. So I think we need to be careful, right, in how we develop these AI models and how we use them to ensure there are no biases in there, right? And the way to do that, by the way, how do we do it, right? How do we gain the trust of the public, right? That how do we know that that these AI systems are actually fit for purpose? So we need to involve them in what I call co-design or co-creation of AI models. That's how you gain the trust, right? To have everybody in the loop right from the outset. Say, guys, this is the data. This is your data. So show them the data, right? Make it transparent and open, right? This is the data. These are the models, and this is how they're making these right and especially wrong decisions. Okay. So that's how you win the trust by co-creating and co-designing AI models and technologies with end users. And then, of course, AI on its own is not going to solve all the world's problems. We need other what I call enabling technologies naturally. So like 5G, 6G, of course. I'm sure you've heard some of these amazing talks, and we work with some of those keynote speakers. I think they were online. Professor Muhammad Imran, for example, he's a pioneer of 6G, 5G, and he works in one of my projects quite closely. So as you know, 5G, 6G opens up huge opportunities, right? Ultra low latency, high reliability. You can have remote surgeries now, in real time, and the list is growing, right, all the time. So wireless wearable sensing, I'll talk about, how we can integrate that with AI and of course, IoT-led edge. Of course, a lot of exciting work on mixed reality now, AR, VR, digital twins. Flexible skin electronics, very interesting area. That's also being worked on by people in the AI community. Robotic cybersecurity, of course, is fundamental there. So this is actually, cybersecurity is interesting in two directions. One is you can use cybersecurity expertise to try and make your AI model secure, so learn from the cyber experts. On the other hand, you can actually, this is one of my kind of focus areas. We look at how we can use AI to improve cybersecurity. Okay, so we work in both directions, and that you'll find that happen in all, pretty much with all the technologies. AI can help improve them, and you can also learn from them as well. Okay. Yeah, so this is one of the use cases we're working on, and this is also with in collaboration with Glasgow, Professor Imran, as I mentioned. So we have this test bed now that we're working on, and this is an example of some of the use cases that we're targeting. Of course, we're not working on all of them. We're working on some of them, the high-value ones. and I've listed them, the ones that we are interested in. Lots of challenges and opportunities, as I said, and one of the things we're trying to do is, of course, as I mentioned, we're ensuring the green, the metric, that how green our models are, is there. And also interested in the biases, right, as well. And of course, we're also always trying to make our models openly available as part of the democratization. So when we train models, we make them openly available so others can actually use them, transfer, learn into new applications and new use cases and so on. Okay. This is another use case we've been working on. It's actually quite close to my heart, actually. So people, to help people with dementia and also cognitive load or cognitive loss or decline, right? So, and I'll talk about that in one of the use cases that I'll touch on later on. Okay. So this is also funded by the UK government, and we're trying to develop these. So we want to make chatbots or robots more emotion sensitive like humans are. So try to understand the emotion of the person and try and respond in an emotion sensitive manner. Okay. So that's still it's a very open area of research, and that can help a lot of people with to improve their mental health and well-being. This is another area as part of trying to make AI models more interpretable. This is more like the three main ways for interpretability is you have your application grounded, you have your human grounded, and functionally grounded approaches. So this is more of an application grounded approach. We carry out experiments in real life, and we're looking at trying to analyze deep linear network models to see which cortical regions, which regions in the brain are responsible for for making a decision on that classification of when you can open and close a hand in response to stimuli. It's quite interesting work we're doing with collaborators at Italy. This is another interesting project we've been working on with Professor Sheikh from University of Edinburgh. He's one of the world's leading pioneers in policy, in health policy research. So this is an opportunity, alhamdulillah, we had during the pandemic. Yeah, and I think this is really for all of us here, really. So if you think about social media and online forums, this is really pretty much untapped data. It's a huge heterogeneous data, right? For AI to actually learn from, yeah, to pick up intelligence and to figure out what's useful to improve people's lives, right? And of course, there's a lot of nasty stuff in there, a lot of fake misinformation. Then how can AI actually help us, uncover, detect, right, and educate people? Okay. So that's something we did. We had looked at, and this is the first project in the world by the Grace Fellow. We looked at social media because we had no other way to access people's, to understand how they were feeling, what their attitudes and experiences were of, the government interventions, as face masks and social distancing and so on. So we worked with the Scottish government on that. Alhamdulillah, so we looked at a number of very interesting, exciting use cases. I've listed them here. And the Scottish government, they did this, doing this online analysis of public to understand and trying to use their, opinion to inform policy making. So we came up with this automated human and expert in the loop tool that we made openly available for them. So previously, as I'm sure most places when governments do these, public consultations, they manually kind of sift through all the data. But you can imagine all the cost and the time. So you can automate that if you have human expert in the loop AI frameworks that can actually automate the learning and they can keep improving over time from the experts that are involved in that process to validate the decisions. So looking at public attitudes towards vaccinations, especially as they were introduced during the pandemic, the very interesting results that came out. And we're still working on that. We're looking at some new use cases that government's interested in. So we're kind of moving to other verticals now as part of that project. So we published it was like a position paper in the NEJM journals, one of the world's top journals, in trying to make people aware of what's possible, from this social media and online forums, right? And of course, what are the kind of risks and the challenges and opportunities there for us. Okay, yeah, I won't have time to talk about this, but this essentially the idea here was that we came up with this hybrid approach, so where we have experts like Professor Sheikh, the policy making expert. He knew what he was looking for, right? So he gave us those keywords and topics. And other analysis was coming up that was data driven, right, from the social media. What are people interested in? And then having that kind of a hybrid approach. And this is interesting. We found these kind of the trends, right, how they change over time. So this was a temporal analysis in that case, and we tried to correlate what was responsible for what peak or what, and of course we're correlating this with other trustworthy means of data sets to make sure that our analysis is reliable and trustworthy. Okay. This is comparing UK and US public attitudes. I'm sure we can do it for other. And alhamdulillah, this paper by the Grace Fellow is one of the most highly cited papers. Other people in the world have been doing similar things since then. And so in fact, what you can do is not just spatial, temporal, but also spatial analysis. You can see how the sentiment or public opinion varies across different regions in the UK, US, I'm sure Pakistan, other places of the world. And then you can sort of deep in and sort of dive in and see what's happening. Why are people feeling more negatively in certain areas, right? What is responsible for that kind of sentiment? And then you can try and address it, okay, as policymakers and so on. And then, alhamdulillah, I came up with this kind of proposal. I said, I think if you think in generally, most societies in the world, right, we're pretty much like reactive societies. We respond to problems, or to situations, to challenges, but we're not actually proactive enough. And it's costing us a lot of, it's causing a lot of problems. In healthcare, for example, it's causing a lot of cost as well, right? So we can try and think, learn from experience. A lot of data out there. We can learn and try and become more proactive in our policy making. So that was my proposal, alhamdulillah. It's published in the NEJM. So basically the idea was that before a government floats a proposal, or before they implement it, as part of consultation, remember social media, you can be reaching out to billions of people, right? Well, or most of your population anyway, if you do it nationally. You introduce a proposal, see how the public reacts, look at their genuine concerns and try and address them, right? Educate them, okay? And then once you see, and then you revise your policy, right, and see again what the response is, then you can see, once you see and you have hopefully the majority of the public on your side, then you can implement it, right? Everybody's ready for it. It doesn't come in as a shock, right? So there's a lot of things you can do with this kind of a proactive approach to exploring AI, right, to improve your society's health and well-being. Okay, and of course there's security as well as part of that. Yeah, lots of challenges, of course. That was the first pilot work we did. We developed this real-time dashboard, that the Scottish government is using, alhamdulillah, they're the policy experts. And you can actually, interesting, you can think of any controversial policy area, you can actually, this framework, the dashboard, by the way, it's openly available if anyone's interested, the website link is there. You're free to sign up and, we'll be happy to support. Okay, challenges, of course, as you can imagine, right? So in social media, it's not an easy kind of world to navigate in, right? So you have multilingual challenges. AI models are currently, custom optimized for certain languages, not for multilingual people. Everybody's like multilingual. Nobody just speaks one language nowadays. So, and then there is that kind of, those kind of terminology, and some new terminologies evolving on social media platforms that AI models are not trained on. So you need to, keep up to date, right? And of course, as I mentioned, fake news, biased, and misinformation. Also tackling all of that to make sure that what you're capturing is reliable. And of course, it's not just text, there's also videos and audios and multimodal, which is really one of my key areas of interest. How do you exploit multiple modalities, right, contextually, wherever it's available to maximize your insights, right, and your decision making and your predictions. Okay, yeah, I think that's, yeah, other applications you can think of, right? So I listed a few over here. So looking at, obviously, we know what the media is like everywhere, which media do you trust and you don't trust. So you can analyze, the objectivity in news articles, and also legislative significance. You can look at, analyze, you can predict, also inform the government's public communications, right? So you can really use this quite effectively in that area. And of course, one very close to my heart is this healthcare, right? In fact, there's an interesting study that came out now. So one group in the US, what they've done is they've linked people's social media profiles with their clinical health records, and they found that kind of linkage gave them a much better capability to predict. For example, one of the applications we're looking at was relapse in patients with this schizophrenia. Okay, so that was clinically, validated, that finding. So I'm sure you can try out other application areas. Okay. Yeah, so this is the last use case I want to talk about very briefly. This is what's keeping me busy and awake at night. So this is, alhamdulillah, by the grace of God. This was actually a UK government call that came out 2 years ago, and they were looking for ideas to improve. So we're talking about proactiveness. So they were asking us to come up with a vision to transform healthcare by 2050, right? So we really had to think very deeply. Alhamdulillah, I was very fortunate by the grace of God. Our proposal came second in the UK. We're one of 6 that were funded, and this is the largest funding in the country in this area of assistive hearing and communication technologies, alhamdulillah. So, and again, by the way, I was talking about this earlier on, and I think if you have that kind of motivation to try and maximize the impact of our research, hopefully God will create those opportunities for us, okay? And the things will sort of come into place for us, okay? And that's what happens. Very fortunate. I managed to bring together, by the grace of God, the team that I needed, the critical mass of world-leading experts, professors from across the world. Well, mostly from the UK, obviously the UK project, but we have international experts as well. The most important, this is what I was talking about earlier on, remember about the need to co-create AI models, right? So we need to have, so our user group is fundamental. is chaired by our distinguished professor of hearing sciences from Nottingham University. And what we have is the actual end users, people with hearing loss, right? Clinicians, as you'd expect, industry partners, and also other academics, like anyone interested in sharing, and learning from us. Okay, yeah, and of course, most importantly, we have a very distinguished advisory board to make sure to keep us on our toes and that what we're doing is right and it's best value for the taxpayers' money. That's obviously fundamental as part of our ethical research. So we have these distinguished world-leading professors from across the world. We just had our evaluation just a few months ago. Fortunately, it's not coming up, otherwise I probably wouldn't be here. But alhamdulillah, they're happy with what we're doing. They give us some very good suggestions we're reflecting and working on. So this is an annual process, okay? So why are we doing this, right? So, well, it's also more personal than this quote I've chosen and I've mentioned here because my youngest brother is deaf. So that I've always had this motivation to try and do something to help improve their lives. And the idea was that what I saw was every time it got very noisy, right? A lot of, especially when you have like cocktail party situations, people talking at the same time. I'll show you a demo of that and you'll see how challenging it is. I'm sure you all experience this. So what they do is you just take the hearing aid off, right? Because it's just useless, okay? And the reason for that is because this is a key thing that if you think about this, called this listening effort. So how much effort or cognitive load do I need to actually exert in order to make sense of what we're hearing? Right? Now it's actually important because we have now all these earphones and headphones. So actually, we're doing some collaborative research with people in the US, and they're looking at so they're looking at how the link between hearing and dementia. And guess what they found? It's very worrying actually for all of us. A lot of people are, because of obviously this increased infotainment and this high exposure to this environmental noise around us, every day. What's happening is that people are, their hearing loss is developing early, but a lot of it is undiagnosed or untreated. People don't actually, just ignore it, and they leave the hearing aids till very late. And what happens? So over time, because of this cognitive load, that we have to exert more cognitive load, listening effort to make sense of things that we're hearing every day. So what happens? What do you think happens over time? And this is now clinically shown that actually it can enhance the onset of dementia. So nowadays you see a lot of young people developing dementia symptoms very early on, and that's one of the key factors. Hearing loss is now directly attributable to dementia. As you can see, imagine how important this is, right? So we need to be looking after ourselves, by the way. Any signs, just go and get yourself tested. Now we're doing a lot of work on this. Alhamdulillah, it's a big ground by the grace of God, so we're working on a lot of exciting areas to try and automate, remote remote assessment, to make it free for people in remote areas as one of our projects as part of this research program. And of course, one of the, if you ask people, why do you not, by the way, the biggest problem with the current hearing aids is, guess what? Is they're actually useless, right? And the reason, seriously, and the reason for that is because they're all based on audio, right? So either, they're, these directional microphones, you're talking to the person, you're facing the person and you try and cancel out noise, or, there's some limited amount of noise reduction or filtering inside, but they're all very, very primitive, right? So what happens is, because of these fundamental performance limitations, because they're useless in very noisy environments, people take them off. So the uptake is very, very poor. In fact, I think I mentioned up there, so 40% of people who are benefiting actually have them, and majority of those who have them, they don't actually use them. So that's why this problem is exacerbating globally. It's very serious, right? And now obviously linked with dementia as well and cognitive decline. So what and social stigma is another factor where people just think, it's like the fear of looking old, even though they're very, people who can afford them, if they have very small ones, but they still, they don't use them. So our ambition, one of the visions sort of for 2050 is to make them sort of skin-based, right? So totally invisible. Of course, it's a huge task for AI, but how do you implement a deep learning network on the skin? How do you get that chip in there, in a flexible chip, right? That's probably 20, 30 years away. Anyway, so that's one of our long-term ambitions. Of course, what we're trying to try and do right away, which we're working on, we've done a lot of work, we'll show you some exciting demos on that, is how can we, again, it's part of, how do we make AI smarter? We need to, again, go back to the best creation, the brain, right? How do we, by the way, we don't know much about it, right? Even the neuroscientists, they know 5-10% of how the brain works, and only 3 to 5% of it is used by people. What about the rest of it, right? So God knows. I mean, the point is, if you look at how do we actually hear as people, now I'm talking to you, now just look at me a bit carefully, and I'm going to try and do something, and I'll see how you all react. What did you all do? Started reading my lips, I hope, because you couldn't hear me, right? Okay, so that's the kind of the secret. So most people, even normal people, if they struggle to hear, right, because it's very noisy, they start reading lips of the target speaker. Imagine people with hearing loss, they lip read all the time, those poor guys. Even my brother, that's what and I said, well, why the hell can't technology do that? So alhamdulillah, that was the idea that I started working on 15 years ago by the grace of God. And alhamdulillah, now we've got to the stage where we're actually getting into the innovation kind of TRL kind of 4 or 5 now, and hopefully we can take it to 6 or 7 by the end of the project, inshallah. So we can, and of course, we want to make sure it is affordable. Keep the profits like the Chinese companies, keep the profit low so most people can benefit. That's been my criteria. I said, look, I'm not interested in working with companies who don't share my vision, right? Okay, I'm not interested in making these affordable. I'm sure enough rich people will buy it, but I want to make it as low cost as possible. Okay, yeah. So that's the grand vision, right? We want to come up with next generation of multimodal or audiovisual hearing aids that can lip read. Easier said than done, right? Okay, and I'll tell you why some of the challenges. So imagine this is how a typical hearing aid works. This is our partners at Sonova in Switzerland that we're working with. It's one of the companies. So you can see already very small. So there's no space to increase, right, in order to fit a deep neural network in. So you have to go to the cloud, right, and come to an edge, and then eventually over time have everything on a chip, with these AI-based FPGAs. I think you had a talk on that, very interesting talk on that. And of course, battery consumption is critical, right? So there's no more room to get any more battery. The processing delay is the most important, right? So imagine I'm talking to you now, right? So as you look at me, so the maximum sort of end-to-end latency for a hearing aid is 10 milliseconds. That's all of the hearing aid processing, right? And if anything more than that, you lose synchronization between what you see and what you hear. Now that is the biggest challenge. Now all of these deep neural networks, their latency is very, very high. So imagine we're having to transform AI research, and we're doing that. Alhamdulillah, we've actually made by the grace of God, some very good progress, and I'll give you some examples of that. Sorry, this way. Yeah, so this is one potential prototype we're currently working on. So as you can imagine, smart glasses, something people don't mind wearing, right? So camera may be somewhere here in the middle, right? And you can lip read the target speakers, lip movements, right? Another visual cues you can pick up as well, contextually, depending on the environment. And of course, so that's our kind of journey, the long-term vision. Hopefully, I think we said to the government, we can hopefully, inshallah, bring this forward from 2050 to maybe 2030, potentially, maybe 2035 max, to get everything on the chip. Now, why do we want everything on the chip? Why do you think? It's privacy concerns, right? Because imagine if you have the camera, would you be comfortable, me sort of filming doing your lip movements? So how do you get around these privacy concerns? They're really fundamental. Otherwise, people won't be interested, right? The society won't accept them, okay? So if everything's on the chip, what's going to happen? Then you'll give the end user, the hearing aid user, the personalization, the kind of choice that he can switch off from the internet, right? And have complete privacy. The data will all be local in the processing, in that hearing aid chip, but that's a long way away. So we've had to, of course, currently we're working on the cloud, we're bringing it down to the edge, to the mobile phone and, the desktop and laptop-based prototypes that I'll show you. And of course, using 5G, 6G in there for the communication to minimize the latency, to try and meet that 10 millisecond challenge. Sorry. Yeah, these are the 3 work packages we're working on. So models, algorithms, and implementations, software, hardware prototypes we're developing, and their evaluation, both clinical, objective, and subjective. So yeah, I won't have time for this. I'm sure you'll all know. So imagine, right, so current AI models, they're all usually optimized to work with one modality, either it's audio or visual or text, but multimodal real-time models are not there. And they're not privacy preserving, they're not green, they're not energy efficient, they're not secure, right, they're not interpretable. So imagine the challenges, right? So they're all like grand challenges essentially out there. Okay, and of course, in the context of hearing aids, all those additional challenges, right, the space, energy, and so on, okay? So this is in short what the challenge is. I'm sure as you know, so you have noisy speech, you want to get rid of the noise. The noise could be of any type, could be speech or non-speech type, and a lot of other applications, automatic speech recognition and so on. Cocktail party problem is the one we've been trying to address. And as you'll imagine, because it's a new type of, it's a fundamentally new approach, if you don't have data sets to train on models on, so we had to record new data sets. Data sets that were out there were useless, recorded in very clean, kind of ideal environments, so we had to record them in real kind of cafe, real very noisy environments. So we did that, and we published it, made it openly available. Yeah, of course, getting as big sample sizes as possible, so lots of evaluation metrics still that are not there. We need to develop new metrics. How do you evaluate audiovisual hearing aids, right? Even audio hearing aids, there are no standards to evaluate them. So a lot of work to do. Okay, so this is we've developed a new baseline model that we've made available. The people can download, you can actually use it, you can play around, and you can actually adapt it for other applications. So this is a real-time audiovisual speech enhancement model, the first of its kind in the world. Latency, this was old, 25 milliseconds, and now we brought it down to 8 milliseconds, fortunately. We still need to go more because we need to integrate this noise reduction with other parts of the hearing aid, processing components. So we need to bring it down to about 3 or 4, so there's still a lot more work to do. Yeah, and as you can imagine, in the real life, there's a lot more challenges, right? So as I'll give you one example of when I went suddenly quiet. So imagine if it goes dark, it happens. Probably more here than, so if you lose electricity, what's going to happen? The camera will fail, right? Maybe if you have other types of sensors, I'll talk about like RF sensors, maybe you can still pick up, but so in general, so, the visual quality is not consistent always, right? And that's the case with any type of data. You don't always get access to good quality data in real time. So what do? You need these kind of generative models, very smart models. You can actually generate those missing bits in the data. Okay, so alhamdulillah, we've kind of worked on that, we've cracked that, and alhamdulillah, we published it. This is, I don't know if it's time to show you this demo. Maybe just a few seconds of this. So this is something, and again, you'll see real data, and you'll see how our processing with lip reading and without, sort of how it works and how it actually helps you improve, the quality and intelligibility of speech. So this is all, alhamdulillah, this is all kind of, the first of its kind of revolutionary stuff by the grace of God, and we made it openly available for these benchmarks for everybody.
And Catania also has a Teatro Massimo. Here it's called Teatro Massimo Bellini, in honor of the local composer Bellini. And it's supposed to be very, very lavish inside. They probably also have tours like we did in Palermo this time.
We've had such a hot summer in the UK, and most of Europe, to be honest. But I feel like Scotland probably just continue to have its
different kinds of noises. You see,
hydration.
See other examples. Everyone with people in the background. Green. This is wind noise, very difficult for audio hearing aids to kind of compensate. But lip reading, sorts that mess, right? Very, very effectively.
Oh my God! We're actually going to the train station in India. You guys don't know about India. Their train stations are lit. Like they're so busy.
That's right. So one of my posters is Indian, so of course. We got that Indian clip, of course, we're all working for the whole world, so. It's interesting, you train the model in one language, does it work in another language? This is something, so multilingual challenges, so we've been working on them as well. This is, that was Spanish, but again, we've tested on different languages, it works, alhamdulillah. So just moving on, sorry, quickly. Yeah, so a demo is available online. Can actually record their videos online, right? And you can actually then listen to the, the noise reduced versions and you can compare, right? Our audiovisual models with audio only and other types of models that the people are now, of course, we're promoting open research in this. We're organizing challenges, and which I'll talk about later on. Okay. Now then, this is our real-time model this is actually very, very important. So think about it now. As I mentioned the challenge of privacy preservation, because otherwise people won't be interested, right? So we said, alhamdulillah, we came up with this idea that even with a camera, what you can do is, if you extract just the lip outlines, movements, and that can make, even your camera-based technology privacy preserving, right? But of course, we need to convince the public, look, this is what's actually being recorded. We're not recording anything else about your face or other personal sensitive data. Anyway, it works in real time. You can track. It's in our demos now. It's okay. It's all right. Yeah, we also have live demonstrators. I think I'll skip these demos. I think it's probably taking a bit longer than we'd hoped. But this is interesting, right? So I hope if you have some time, go to this our program website, and this is the world's first challenge that we organize in audiovisual speech enhancement. So multi-speaker separation. Again, we want to work with real problems. Remember, high-value use cases. We don't have time to be wasting on kind of just trying to publish things. We want to get the work done, right? So this was real TED Talks that we actually put together. So here's two speakers talking, and again, you can see the power of this lip reading or multimodal AI technology, which is privacy preserving as well. This is two people talking, so with and without. It's okay. You can listen to it online. Okay. So and for three people as well, it's very interesting. It's more challenging, and that's where the limit currently of our models, right? It can't go, sort of beyond the three models currently. I mean, it's struggling. We're still working to refine and optimize for more than three speakers. Okay, and at the same time, we're also working on. Remember one of the points I mentioned about trustworthy and responsible AI, we need to ensure our models are green, energy efficient. So that needs a whole new kind of paradigm of thinking. So alhamdulillah, we're working on that as well. We're coming up with new energy efficient deep neural networks. We're also, obviously, because they're very expensive computationally, we have to go to hardware. So we're implementing them on, on AI-enabled FPGAs as well. And at the same time, mashallah, publishing in top journals, as we're expected to. And of course, the biggest challenge, integrating it all within the rest of the hearing aid, right? So that's probably the biggest challenge, right? All the rest of the, the signal processing, the delays and the latencies, and yeah. So I think the last point there is very interesting. So I came up, with this idea that so other than cameras, we should have other modalities, right? So RF sensing was again my collaborators at Glasgow. So they've been working on this to detect people's, kind of macro movements, like when they're standing or sitting, which is good to detect the context if a person is facing you or not. But I said, I'm not interested. Can you actually lip read? They said, well, we never tried it. I said, let's try it then. We got the funding, let's go and do it. So alhamdulillah, they tried it, and guess what? It worked, right? So this was now just published in Nature Communications, alhamdulillah. So it just shows, you just think out of the box, you never know, right? Okay, with the right vision, right motivation, that's obviously key to get that barakah, as we call it, to get that good luck. Okay. Yeah, other applications. Yeah, so people are welcome to come and talk to me afterwards if you're interested. Lots of other things we can do, exciting applications, opportunities with this audiovisual speech enhancement technology. Also an example of innovation, also commercializing technology. Mashallah, one of our startups, spin-outs to the university, mashallah, just taken up for £30 million. But that, the main satisfaction with the Scottish government was looking to protect their end-to-end, platform to detect insider threats. People who are, selling, secrets or data and things. So alhamdulillah, they chose our platform over everything else in the world that was available. So that was alhamdulillah satisfaction. Also, you can detect deception, lying. People are, so we came up with this first multimodal approach, right, to detect if people are speaking the truth or not. Probably be of interest to a lot of security people. Also, smart cars is where we're looking at modeling people's behaviors. Can you make smart cars that can act more responsibly? Alhamdulillah, by the grace of God, our team won the first prize. Since the pandemic, they stopped the competition, but we came first in one of the international challenges with our collaborators in China. And just very briefly, finally, just calls for participation. This is a previous conference we organized. It's the world's biggest WCCI conference in Glasgow. But this is the one that's happening every year. So if you're interested,